Welcome to this lesson on molecular compounds. Today, we're exploring a fundamental type of chemical bonding that occurs between nonmetals. Molecular compounds are all around us, from the water we drink to the air we breathe. Let's dive into understanding how these important compounds form and what makes them unique. Molecular compounds are formed when two or more nonmetal atoms come together and share electrons through a process called covalent bonding. Unlike ionic compounds, where electrons are transferred from one atom to another, in molecular compounds, the atoms hold onto their electrons while sharing them with neighboring atoms. This sharing creates strong bonds that hold the atoms together in discrete molecular units. Molecular compounds have four key characteristics that distinguish them from other types of compounds. First, they involve electron sharing rather than electron transfer. Second, the atoms are held together by covalent bonds, which are strong attractive forces. Third, molecular compounds exist as discrete molecules, meaning they are separate, individual units rather than extended crystal structures. Finally, they typically have lower melting points compared to ionic compounds, because the forces between separate molecules are weaker than the bonds within each molecule. Let's look at the most familiar molecular compound, water. Its chemical formula is H2O, which tells us that each water molecule contains two hydrogen atoms and one oxygen atom. These three atoms are held together by covalent bonds, where the hydrogen atoms share their electrons with the oxygen atom. This sharing allows all atoms to achieve a more stable electron configuration, making water a stable molecular compound. Many common substances are molecular compounds. Carbon dioxide, or CO2, is the gas we exhale and plants use for photosynthesis. Ammonia, NH3, is used in fertilizers and cleaning products. Methane, CH4, is a major component of natural gas. Oxygen gas, O2, is essential for respiration. Nitrogen gas, N2, makes up most of Earth's atmosphere. And hydrogen chloride, HCl, is a compound that forms hydrochloric acid when dissolved in water. All of these are formed by nonmetals sharing electrons. It's important to understand how molecular compounds differ from ionic compounds. Molecular compounds form between nonmetal and nonmetal atoms through electron sharing, while ionic compounds form between metal and nonmetal atoms through electron transfer. Molecular compounds have lower melting points because the forces between molecules are relatively weak, whereas ionic compounds have higher melting points due to strong electrostatic attractions in their crystal lattice. Additionally, molecular compounds are poor conductors of electricity in any state, while ionic compounds conduct electricity when melted or dissolved because of their mobile ions. Molecular compounds exhibit several distinctive properties. Many are gases or liquids at room temperature due to their relatively weak intermolecular forces. They do not conduct electricity in any state because they lack charged particles that can move freely. Many molecular compounds dissolve well in nonpolar solvents, following the principle that like dissolves like. And while the covalent bonds within each molecule are quite strong, the forces between separate molecules are much weaker, which explains many of their physical properties. Let's summarize what we've learned. Molecular compounds form between nonmetals through covalent bonding. In this process, atoms share electrons rather than transferring them completely. Common examples include water, carbon dioxide, and ammonia, which are all essential to life and industry. Molecular compounds have different properties compared to ionic compounds, including lower melting points, poor electrical conductivity, and often existing as gases or liquids at room temperature. Understanding molecular compounds is fundamental to grasping how matter behaves at the atomic level.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.